Hey guys, welcome back. In the series of learning programming in C, in the previous videos, we have already discussed about unary operators, arithmetic operators, relational operators, and assignment operator. In today's video, we will discuss about logical operators. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. So let us talk about the logical operators. So first of all, we should know the meaning of logical. So when we say we are writing the program and we have to think about the logic, means it is nothing but the statement on which we take the decision as either true or false. And we all know the Boolean values. True represents 1 and false represents 0. I can say this 1 which is in on condition and 0 which is in off condition. I can say this Boolean value 1 which is high state and this 0 which is in low state. I can say this is the statement say yes and this is the statement say no. So the Boolean values 0 and 1 is used to analyze the logical statements. So the logical operators that what we use here decides whether the statement is true or false. So let's talk about the different types of logical operators. So we have 3 types of logical operators. This is double AND symbol, which is called as logical AND. This is pipeline symbol that what we use in DOS mode and all, which is logical OR. Then exclamatory symbol, which is logical NOT. So these AND, OR, NOT will have the general meaning of the statement that what we use in English. And, I say this and that. Or, I say this or that. Then NOT, it is nothing but the reverse. So and says, for example, I say I want both coffee and snacks. It means to say both should be satisfied. Or says I can have coffee or tea. I'm just explaining in general scenario. And not says, say I just say I want coffee, then they'll say no, you have tea. So it is the complement, the reverse. So we have the general meaning of and or not. Now let us see how this is going to work with operands. As a logical operator is a binary operator, obviously it requires 2 minimum operands. I just say, let us assume, so let us see how these logical operators works. With 2 operands I just take, I say A equal to 0 and B equal to 1. Then I say A and B. So what is A? It is 0 and what is B? It is 1. So here we are taking the Boolean values. So it says 0 means false and 1 means it is true. So and says both the conditions to be true. But here A is 0 and B is 1. So A and B, it means to say one condition is false and other condition is true. So my result will be false. And says both the condition. If any one condition goes wrong, the result will be false. Whereas if I apply the same value with or, I say A or B. What is the value of A? It is 0. What is the value of B? It is 1. A is false, B is true. So here any one condition, if any one condition is true, then the result will be true. This or that. It is good enough to have the result as true. So my result will be true. Then I say not. It is the complement. I say not of A. So A is having 0. Not of A means it becomes 1, which is true. I say not of B. What is B? It is 1 and the complement of 1 it is 0. So it is false. So to make you understand the values of these operands, let me explain this with the truth table. But one thing that what you have to know here is, and says all the conditions to be true. If any one condition goes wrong, the result will be false. All the conditions true, then the result is true. If any one condition goes wrong and if all the conditions goes wrong, obviously the result is false. Whereas OR says this or that. All the conditions true, well and good, true. If any one condition is false in between, then the result is true itself. Any one condition true, the result is true. Not the reverse. I give 0 as input, I'll get 1 as output. I'll give 1 as input, I'll get 0 as the output. So this is what with the logical operators and or not. I'm going to explain this with the truth table, which will make you understand still better how these logical operators are going to work. So let us see how this logical operator works in detail. So we'll talk about logical AND. So here we have logical AND operator. So this is what the symbol of logical AND. So this is one expression. The first expression that what I am comparing is 7 equals to 8. So whatever the result I am going to get, this is the first expression, and let me treat this as A. So what is the outcome of A? Is 7 equals to A? Well, we have studied about the relational operator. It is equality operator. Is 7 equals to 8? No. The condition is false. False means what is the Boolean value? It is 0. Let me take this expression 2 that what I am having here as B. Now check. Is 4 equals to 3? Is 4 equals to 3? No. Again the condition is false. So my answer is 0. So let me write column A, column B. What is the result? That is the answer of C is A and B. So I should write the values now. What is the outcome of A? It is 0. Outcome of B? It is 0. According to the logical AND, what is A and B? AND says all the conditions to be true, but here all the condition is false. So obviously my result is false. Let me change the value now. Let me have the one more expression. Actually, when I say logical operators operates on 1 or 2 or more operands. So minimum 2 operands we require. So here the first operand is an expression. The second operand is also an expression. So I can say the logical operators works on 2 or more expressions. When I talk about the relational operator, the relational operators works on 2 or more variables. So variables are acting as operands in relational operation. Whereas here in logical operations, expressions are acting as operands. So here expression 1 is operand 1 and expression 2 is operand 2. So what is expression? We have already discussed. What is expression? It is nothing but the combinations of operators and operands. So we have operator, we have operands, inputs, variables. So this is one expression. This is one more expression. I am giving 2 expressions to this logical operator AND. So logical operators operates on 2 or more expressions. So the result of the first expression, I'll treat it as A, and the result of the expression 2, I'll treat it as B. So what is the outcome of A? It was 0. Outcome of B, it was 0. So let me change the values for the next scenario. I say 7 equals to 8. The condition is false. Let the first expression be the same thing. So what I'll do here for the expression 2, I say 3. Is 3 equal to 3? So here 7 equals to 8. Condition again it is 7 equals to 8. No, condition not satisfied. The result is false. So it is 0. Then I say 3 equals to 3. Yes, the condition is true. So my output will be 1. So here I say 1. The first expression result is false. Second expression result is true. So my output is false only. Because and says, I want all the conditions to be satisfied. One condition gone wrong there. So my output will be false. Next. So let us have one more criteria. I'll say 7 lesser than 8. 7 lesser than 8. Is 7 lesser than 8? Yes. My condition is true. So I'll say 1. Is 2 equals to 3? No. The condition is wrong. 1, 0. What will be the output? Again it is 0. So here 1, 0. First expression result is true. Second expression result is false. True, false. My output will be false. Let me have one more. 7 less than 8. I'll say 3. 7 less than 8? Yes, true. 3 equal to 3? Yes, true. So both the conditions true. First expression result is true. Second expression result is true. Obviously the result is true. So I think you have understood how the logical AND is going to work. So it is going to produce the result as true only when all the conditions are true. So here I have just given two conditions, two expressions. You can have more than that also. 2 or more expressions. Say I have n expressions. Then all the n expressions result should be true. Then only the result will be true for logical AND. All the conditions false? Obviously false. Any one condition false? So here it is false. Here it is false. The answer is false. So this is with the logical AND. Hope you have understood this. So let's talk about logical NOT. NOT, I said, it is like complement. I give the Boolean value true, I'll get false. I'll give false, I'll get true. So let us check this. I have the expression which is A. The expression is 7 less than 3. Is 7 less than 3? No. The condition is wrong. 7 is not less than 3. So my Boolean value is 0. Now what I'll do, I'll say not of A. So A is 0. A is 0. Not of A means my output is 1. So it is true. I just make it as (17) greater than 3. Is 17 greater than 3? Yes, the condition is true. The condition is true. Yes, 17 is greater than 3. My answer is 1. Now I say not of A. So A here it is 1. Not of 1 it is 0. My answer is false. So this is how we work with logical NOT. So that's all for today's video. In the next coming videos, we will just check out few more operators, and please stay tuned to my channel. We will have the execution of all these programs. Till then, take care. Bye-bye.